Hey, Bogdan Brzeski here with another video where we make solving quadratics easy just for you. In this particular video, completing the square method. Let's dive in. Quick refreshment of your memory. When you see an equation and identify the first coefficient beside x squared is non-zero, so that means you truly see quadratic equation because that expression is equated to zero, then you have a quadratic equation to work with. So, first example. You remember that example from factoring method? In this particular video, example number 1 would be factored because the first coefficient needs to be taken out, completely factored out from the statement so that you can proceed with completing the square method. So everything divided by 4 gives you x squared, 3 over 2, and negative 5 over 2. And you will carry that coefficient 4 until it's no longer required. So down below, the method is similar to when factoring or working with perfect square trinomial, when you try to complete the square so that you can shrink the trinomial into a binomial raised to the power of 2. So the middle term is always divided by 2 right here, and then you insert 0. In algebra, 0 means insert one quantity and subtract at the same time. So this is showing right here. So 3 over 2 divided by 2 is 3 over 4, and then you raise to the power of 2 and you insert 0. So the first 3 terms that you can see is a perfect square trinomial, so this is compacted right down below. And then you have to resolve what is this all about when you raise 3/4 to the power of 2. Combined with negative 5 over 2, you have to have the same denominator, etc. So we'll walk you through this. So look, the coefficient 4 stays. Now we have compacted this trinomial into a perfect square binomial. Then you have minus 9 over 4 because it says minus this fraction squared, and minus 5 over 2. When you combine these two terms inside of the bracket, you have to account for the same denominator. So that's the strategy. So at this time, the outer coefficient 4, the common factor, is no longer serving us. We can divide both sides of equation by 4 because we can. This is an equation. We're working with expressions. You can't do this. So divided by 4 in order to eliminate because it does not impact the roots of that quadratic equation. So right below you see no longer coefficient 4 with us, but we can continue working with that equation. Solving for x is the goal here. So you have to add those two numbers and then you have to bring them over to the opposite side because in the end we have to isolate for x. So you keep this binomial x plus 3 over 4 outside squared. Common denominator 5 over 2, you want to create 16, so times 8 top and the bottom. And then in the end, this is negative 49. When you transpose this location, you get positive 49 over 16. So this is a very important step right here. You do the square root of this binomial and square root of that constant. Coincidentally, 49 over 16. So each number is a perfect square number, so that's beautiful. But the result of that is either positive 7 over 4 or negative 7 over 4. On the left side also, in theory, you would get plus or minus result, but out of 4 cases, 2 would be redundant because it would be the overlap duplication, so we just stick with 2 possible cases. So this result, x plus 3 over 4, is equal to negative 7 over 4 or positive 7 over 4. This is why you see this double sort of operation in one spot. So you split into two equations. One time you would say negative 3/4 plus 7 over 4. The second time around, negative 3/4 minus 7 over 4. Why negative 3/4? Because that positive 3/4, when you move over to the other side by subtracting 3/4 from both sides, you generate negative 3/4 on the right side. So when you add those two fractions, you get beautiful 1. Add the other group of two fractions, you get negative 5 over 2. You know that this works. You can test it by verifying it. You've seen it by solving by factoring. So everything adds up nicely. Next example, with more challenging situation perhaps, because we have negative coefficient a, but whether this is negative or positive, your first order of business is to extract that coefficient entirely from the entire equation so that you have 1x squared with positive sign in front of it. So divide everything by negative 3, beautiful, and account for change of sign. So then we're going to divide that new factor, negative 7 over 3, divided by 2. It shows right here. So this is the middle term, perfect square trinomial connection. Divided by 2 and insert 0, because at any time you can add 0. Whether you have an equation or expression, you can add a 0 to that statement. So our 0 is the result of the division raised to the power of 2, and you add and subtract the same quantity simultaneously. So the first three terms is always converted into perfect square trinomial. Those remaining numbers you will add together to make it simpler. So x minus 7 over x is the result of that conversion in brackets squared. Please note that negative 3 stays with us at this time still. We haven't eliminated yet. Then 7 squared is 49. 6 squared is 36. Now inside we had negative fraction, but when you raise to the power of 2 it becomes positive. So that minus sign comes from here, right? So minus 49 over 36, take away 2. So these two terms will be combined. But before we do that, we divide now by negative 3 both sides, because we have an equation, so that negative 3 is no longer serving the purpose, it's not needed. We could have divided in the beginning. For some of you that is familiar with this procedure, when working with equation, you can divide or multiply both sides by the same non-zero value. You could do it at any time. So I have decided to eliminate negative 3 from this line. So from this point onward, I'm just focusing on finding x, period. So when you combine those two terms together, common denominator. So 36 is the common denominator. When you add those two numbers, you get 121 over 36 with negative sign. When you move this over to the opposite side, you get positive 121 over 36. So this is the step where you want to eliminate the exponent by factoring both, square rooting both sides, right? And we know already from the previous examples that when square rooting a number, you get two possibilities, positive results or negative results. We would also get the same two options, positive or negative results on the left side. There is overlap. Out of 4 cases, 2 are redundant. Therefore, you keep this as positive, x minus 7 over 6, and then you solve it for those 2 cases when combining positive 7 over 6 either with positive 11 over 6 or with negative 11/6. So it is showing right here. When you move that negative 7/6 to the opposite side, you add and then you subtract, and then you complete the addition for both cases. You get the roots. Bingo, we have the solutions. Now, verification steps. You should always be able to verify by substitution. If you use +3, that's sort of easy. If you use -2/3, it's more challenging but more interesting because you're improving your skills. So let's do it. You would calculate this total here by using the BEDMAS. So first you square it and then you multiply by -3. Then you multiply by 7 this fraction. Then you create common denominator. And you see that the answer is 0. So hopefully this makes sense. And let's go to the next example with fractions. Remember that example we did in previous video when we factored 2/3 instead, 4/3. The reason that we have to do away with 4/3 here as a common factor because we want to keep x squared by itself, positive x squared. So everything is divided by 4/3. There you go. This goes out. Then you have new adjusted value, 5/2 and -3/2. So this is the common factor that would stay with us for some time, and then we will get rid of that. You could have done it right away, right here at this stage. So we didn't, therefore the procedure follows as such. The middle term, the new middle term, divided by 2, which gives you 5/4, and then we add 0. When we insert 0, we raise to the power of 2, and then we subtract the same fraction raised to the power of 2. So the first 3 terms, as usual, are converted to perfect square trinomial. So that's the whole point when you create this new trinomial with single x squared coefficient equals to 1. Then we try to identify what is the actual perfect square trinomial so it can be compacted into to binomial to the power of 2. So x plus 5/4 raised to the power of 2 minus 25/16 because of that, and minus 3/2 with adjusted common denominator. So times 8 times 8 minus 24/16. So we'll be adding these together, which is -49/16. So at this point, we were able to divide it, both sides by 4/3 to simplify the equation. And then our goal from here on is to isolate it for x. So let's go and do it. Separation step, so -49/16 over to the other side becomes positive. Conveniently, it's always like that. It's a perfect square trinomial with those examples, conveniently. There are cases that you will see that there are not perfect square numbers inside of a square root. But in those questions that we selected here, it sort of lands into a nice reading. So 7/4 plus or minus, we understand why. And then 5/4 needs to be moved to the other side. So -5/4 either plus 7/4 or -5/4 minus 7/4. When you combine these two, you get 1/2. When you combine the next two, you get -3. Bingo! We solve this by completing the square method. It is a lengthy method, a strategy that it's not really very practical. You can do it, but you will see in the next video solving it by using quadratic formula that you're saving a lot of time using that beautiful tool. But for now, please don't go away before you do complete this practice questions. I hope that video helped you to understand how to use this completing the square method. Share with your friends, subscribe to this channel, and we'll see you in the next video. Bye for now.